1.4 Solving Absolute Value Equations Notes, Day 1. So if we have absolute value, so it's a little bit different than, remember our absolute value of say -4 is positive 4, meaning that all answers are positive. Now, the reason why that it is because it's how far away from 0 is -4, and that is what the meaning of that absolute value means. Now, when we're solving absolute value, our variable is going to be inside the absolute value, not different than this one, but it relates to it. So let's start with the equation absolute value of x equals 2. So what number can we put in for x that'll equal 2? Well, we know that there's a positive, so the positive side is x equals 2. So if we substituted 2 in for x, the absolute value of 2 is 2. We also have the negative side, the -1, where x equals -2. So if we substitute -2 in for x, the absolute value of -2 is +2. So they both have the solution of 2. So we've got two answers that are true for this equation. And this is kind of our first time in seeing that. So it could be -2 or it could be +2. Now, when we plot those on a graph, what we're going to do is plot those points on the graph, not above the graph, on the graph. So it goes on the number line. So we're going to plot those 2 points on that number line. So we can look at and see, well, how far away from 2 is 2? Well, we can see that 2 is 2 away. We can also see that -2 is also 2 away. So that right there is our answer for our absolute value. So our answers are located in this spot, how far away from 0. Now, the other number that we have here is 0, and that will, because remember when we said how far away from 0 is this answer 2, that is 0 in that middle position. So there's a couple different ways we could write it. We could write it as the answer as x equals -2 or x equals 2. We could also write, that's one way of writing it. Another way we could write it is x equals -2 or 2 with a comma in between it. Or the more sophisticated way, the algebra way that we use, is that x equals plus or minus 2. And we kind of work towards this. If you only see one answer here, you might want to back up one and kind of use the -2, 2, because this is our first time where we're seeing 2 solutions to an equation. Before this, we've only had one equation or one solution to each equation, but now we have 2 because it's an absolute value. So now when it gets more complicated, we've got we have to think about it a little bit more. We can use our understanding of absolute value. So if we have x plus 3, the absolute value of that equals 5. So now what we can do is think about, well, how did we solve that one above? Well, we kind of broke it into the 2 parts, the positive side and the negative side. So we're going to do that here, the negative side and the positive. I go negative on the left-hand side, the positive on the right. Doesn't really matter which one's which, just as long as you kind of pick away and go with that one. So I like to put my negatives here because I like my negatives first coming and then my positive side. So now what we're going to do, if you notice up here, this absolute value of x was kind of on the left-hand side. And then what changed is the answer became negative and positive side. So what we do is we take and write x plus 3 for both of them. x plus 3. That doesn't change. The absolute value doesn't change. What has changed now is that minus 5. One side is negative 5 as the solution, and the other side is the positive side of the solution. So one's negative 5 and one's positive 5. And when we go ahead and solve that, well, remember there's an or in between here, like we had written up here, one or the other works. So when we solve it, we just go ahead and we solve just like we do now with regular solving equations. Subtract 3 from both sides. Now what's cool about this is since it's the same over here on both sides, it's minus 3 on both of them. So the negative 3 cancels out the 3, and we're left with x equals for both of them. And negative 5 minus 3 is a negative 8, or 5 minus 3 is 2. So our solutions, x equals negative 8 or 2, will be our solutions that make this equation true up here, this absolute value equation. Both of them, because one of them, the negative 8 substituted in, will be negative 8 plus 3 is negative 5, and the absolute value of negative 5 as order of operations is a positive 5. If we substitute 2 in, we get a 5 positive. The absolute value of positive 5 is 5. So when we go ahead and plot those solutions, we can plot those down here. We've got negative 8. Remember, on the number line, we plot the points on the number line. And when we have this other one here, what we can do is find those in-betweens. So we can kind of look for, well, they were both 5 away. So 5 away from 8, if we think about that, 5 away from what is negative 8? Well, it's this negative 3. And where did we see that negative 3? Oh, it's right here, this negative 3. So we translated, or we shifted from that 0 left 3. So we can see that there's 5, 2 is 5 away from that middle 2. So we can look at that 5 and 5. That number is the answer. So we can see that that's the answer to our absolute value. Now, this negative 3, if we go back and look at the very beginning, we kind of look up here and go, hey, it is related to that positive 3. So we can kind of look inside there and go, hey, well, it starts as a positive 3, but then it translates, it gets to undo that plus 3, it has to be this minus 3 here. So this has to be subtract to tell us which direction it's going, which if it's going left or right, because right now it looks like it's going to the right, positive 3, but it is a negative 3. So how I like to write that is I like to write it as x, the absolute value of x minus a negative 3, and put that negative 3 in an absolute value. So this is that negative 3, and this in between, if it's not negative, we need to make it negative. So needs to be subtract. So if it's not subtract, we make it subtract. And that will tell us which way it's going. So I can see now that's a negative 3, so that would be a left 3 going negative 3 down would be our middle term. So our next example will be 3x plus 9 inside the absolute value minus 10 equals negative 4. So our key here is that we have to get the absolute value by itself. So we want to get the absolute value by itself. That's the first order of business. Get it by itself. And right now I see that it's not by itself. It has this minus 10. So I need to add 10 to both sides to get it by itself first before we can do anything else. So the absolute value of 3x plus 9, bring that down. We haven't done anything with it yet, equals positive 6. So now we're going to have the negative side and the positive side. So we've got 3x plus 9 equals negative 6, or 3x minus 9, no, plus 9 equals a positive 6. And then we solve like we normally do. So minus 9, minus 9. I kind of like to do those together because they're the same almost, except when we do the calculations over here. So that would be negative 15. 3x equals negative 3. Divide both sides by 3 on both of them. Those 3's cancel out, those 3, so we're left with x equals negative 5 and x equals negative 1. So we've got our 2 points, our solutions, negative 5, comma, negative 1. And those are our solutions. So to graph that, we'll make a number line. Now remember, when you make your number lines, you want to make sure that they are even. And you kind of do a little bit more. So we want to make sure you have all of them and they're even. We don't change the scale because we need a little more space. What we do is we extend our line if you need that, okay? So I usually start at negative 1 less, negative 5, negative 4, negative 3, negative 2, negative 1, and 0. So I'll plot my point at negative 1 and negative 5. And I kind of see that middle number as negative 3. I've got 2. It gets a little weird when there's more things happening in the middle, and we'll learn about those later on. But basically, we're just going ahead and solving like an absolute value equation. So, for example, 4, we get a little bit more complicated. So the absolute value of x, so we'll go back to the little simple. What number can we put in for x that will equal negative 2? If I put a 2 in there, that's the absolute value of 2 is positive 2. That won't work. If I put a negative 2 in there, negative 2, the absolute value is a positive 2. So there is no number that when we substitute in will make a negative absolute value, or an absolute value a negative number. So this is no solutions. So no solutions will work in this equation. And when we graph it, all we do is put a little number line in, making sure that they're the same width-wise, that scale. So negative 2, negative 1, 0, 1, and 2. Usually we go from negative 2 to 2. Gives us a good kind of, and that would be our graph of the no solutions. So the graph of no solution, there's no points on it, so we just leave it blank. Number 5, example 5. Now, when we get more complicated, I'm going to have to scroll down here. So when we scroll down, we can see at 3 absolute value of x minus 2 absolute value, closed absolute value, plus 9 equals negative 18. So now, first off, we want to point out that these are absolute values. They are not parentheses. So let's write that down so that we are not confused. These are not parentheses. And that is important. So you cannot distribute. Cannot distribute. because they are absolute value. And absolute value, how we solve absolute value is there are two solutions. So we take a positive and a negative. Now, the first thing we have to do, though, is get the absolute value by itself. That is the first order of business. So how we get that by itself is just like our normal solving equations. So subtract 9 from both sides, bring everything else down. It's really tempting to want to distribute now, doesn't it? But it's not. It is an absolute value, and you cannot distribute. So negative 18 minus 9 is 27, negative 27. I was had a wrong number down, so I was like, wait a minute, I had to recalculate. So now, see how we have a multiply by 3? So to undo that, instead of distributing, we're going to divide by that 3. So to cancel that 3 out by undoing it first. Now our absolute value is all by itself. And as I noticed that there's a minus number here. That's subtract. So it's sort of been like translated 2 to the right, because that would be a positive 2. So I've got an absolute value that is a negative number. So right here, I can kind of break off and go, hey, there are no solutions. Now, what happens a lot of times, though, is in these complicated ones, what happens is we start to get into our solving mode. And yeah, we can solve. What's kind of interesting is when we get complex equations, we can continue on solving. So let's pretend that we didn't see that this absolute value is negative, and we continued to solve negative and positive side. That's how we undo the absolute value. In solving, to undo that, we have a negative and a positive. So x minus 2. So a negative of a negative is a positive. And x minus 2 over here. And then positive of a negative is a negative. So when we solve, we do come up with solutions. And this happens in our upper level mathematics. So what we have to do is check our answers. Remember when we would always make sure we substitute back in and double check that it works? Well, that's what we're going to have to do now. So let's take 11 and substitute it back in here. Here's our check. So we'll check on this side. So 3 absolute value 11 minus 2 plus 9. That should equal negative 18. So 11 minus 2 is 9. So the absolute value of 9 times 3 is 27. Bring down my plus 9 equals negative 18. Plus 9 equals negative 18. So 27 plus 9 is 36 equals negative 18. And we notice that these are not true. So what that tells us is that this does not work. And we did all the math correctly. We calculated correctly, and we took the absolute value correctly. And so what it says is that that solution does not make that true. So our next substitution, our next check is the other one, because this one might work. So 3 times the absolute value of 7 minus 2, close absolute value, plus 9 equals negative 18. So the absolute value of 5 is 5, times 3 is 15. We'll bring down that plus 9 equals negative 18, plus 9 equals negative 18. And 15 plus 9 is 24 equals negative 18. And that also is not true. So that means that negative 7 does not work. And remember, when we were solving this before, this is a no solution. And where did we solution? So that no solution answer is important, because right here, if we notice it right here, this spot right here, we could have written no solution and been done with our equation, because the absolute value is by itself. We couldn't do it up here because the absolute value wasn't by itself. When we get the absolute value by itself and it equals a negative number, then we can say, hey, it's a no solution, and we don't have to do any of this down here. We've saved ourselves some time in solving. Now remember, if we had to graph it, we need to show the graph of a no solution. So -2, -1, 0, 1, and I'll throw the 2 in up there. All right, and that is how you solve absolute value equations.